Everyone, so we're going to talk a little bit about short circuits today. Excuse me, short circuits today, circuit breakers and fuses. Just watch that video real quick. Don't try it at home, and then come back here once you're done with that. All right, so hopefully you checked out that video. My question for you is, why did the gum wrapper light on fire? So the reason sometimes they call these prison lighters, if you recall, if any of you ever watched that show, Orange is the New Black, that's how they would light their cigarettes in prison. Things that you should never be doing anyway. So you wouldn't know that, but that's what they would use to light cigarettes in prison. So why did the wrapper light on fire? I'm not going to give you the answer there. Just think about it and come up with an idea. So we're going to kind of explore that question a little bit today. So what I want you to do is open up this FET simulation one we've seen before, and you're going to make two circuits, one with a battery, wires, and a light bulb, and one with just a battery and wires. All right, so we're going to have two circuits. One is just going to have, well, it's going to have a battery, wires, and a light bulb. And the other is just going to have battery and wires. All right. So hopefully we notice something's going on here. All right, the reason it doesn't look like the electrons are moving in the one on the left is because the one on the right is kind of taking up all the, I don't know, the computing capacity of the program, I guess. We should also use conventional current, which goes the other way. It's a good habit to have. All right. So why is one lighting on fire but not the other? That's our question. Why did the circuit without the light bulb light on fire? So you might say, and you wouldn't be wrong in saying this, there's no light bulb. But even more important, what does the light bulb have? What does it provide in the circuits? Using Ohm's law, does the light bulb provide voltage, current, or resistance? Here's a hint, just look at the light bulb, click on it. The light bulb provides resistance. Okay, so therefore, there is no resistance in circuit. Now, I guess I would be kind of wrong in saying there's no resistance in the circuit. Do those metal wires have resistance? Yeah, but so little resistance that it's pretty much negligible. So we don't really, it's basically 0 ohms of resistance. All right. So remember like some of the examples we were using. Voltage, or the battery or voltage pushes the current, okay, and resistance slows it down. If you think about it, there's nothing slowing the current down in the circuit to the right. So the electrons go really, really, really fast. A lot of friction, right, between the electrons and the material that make up the circuit. A lot of friction. If you rub your hands together really fast, they get hot, right? This gets so hot that it can start a fire. All right. So looking at a little bit of math, if you recall, we have the equation Ohm's law, R equals V over I. I always rearrange it though. I equals V over R. So as R gets really small, what does I approach? So let's say R got really small, I gets bigger, right? Well, what if, and think about this in calculus terms, as R approaches 0, okay, so let me get rid of R and fill it in with a 0. You might say this is undefined, but from a calculus perspective, let's say it's really, really, really close to 0, like, but a smidge over it, like 0.000000001. What would happen to I? Okay, I approaches infinity, right? So the current gets really, really, really big when there's no resistance. And that's a problem because that can start fires. Now, we have a few things that help us prevent these fires. One of the things you all have in your homes are circuit breakers. Basically, a circuit breaker, what happens is when the current gets too high through a circuit, the circuit breaker pops, basically breaking the circuit, so no fires start. That's why sometimes you have to go back down to your basement or wherever your breaker box is and flip the breaker to reset it. Now, breakers, they're not big. They're probably about the size of like a wallet. So we can't really put them in all electronic equipment. So if you had a piece of electronic equipment that didn't have circuit breakers in it, you have these little things called fuses. Basically, what a fuse is it's a really thin piece of metal, and if the current goes over a certain number of amps, the fuse burns out, effectively breaking the circuit. It's like the weakest link. And since you know where the fuse box is, you just take out the old fuse that burnt out and put in a new one. It's not as convenient as a circuit breaker because you can't just flip a switch. You have to get a new fuse, but it does work for things that are pretty mobile. I believe that like your cars have fuse boxes in them. So if there's a short circuit in your car, to prevent that, you have fuses, and the fuse box in your car depends where yours is. Mine is like by like where my left foot is in my car. Sometimes there's a breaker box in there or a fuse box in there. But let's look at how fuse boxes actually work. All right. Or excuse me, how fuses actually work. So I am going to get rid of this circuit on the right here. All right. So I have this one here. I'm going to change some of the settings. I'm going to make the resistance on this pretty darn low. All right, let's make it like 3 ohms. Now let's go 2 ohms. Notice how it got brighter. Now think about this happening. Let's say there's like a power surge. You've all used that word, heard that word before. Or maybe you just hook something up to too strong of a power source, whatever you did. The voltage gets really high. Oh no, look at that. Fire started, right? That's a problem because fires are bad, as you hopefully know. All right, so how can a fuse fix this problem? So what I'm going to do is I'm going to insert a fuse. I'll throw another wire in just to make it look a little nicer. And let's get a fuse. Now, ooh, fuse popped already. So let me turn the voltage down a little bit again. So this fuse is rated for 4 amps. So if the current ever goes over 4 amps, let's rate it a little higher. If the current ever goes over 7 amps now, the fuse is going to pop, okay, and kill the circuit, preventing a fire. All right, so let's see. Maybe I should make this, let's rate it for 14 amps. All right. All right. So right now, this has 14 volts. This has 2 ohms. If you wanted to do the math, you could figure out that the current here is, let's see, V over R, 14.5, so 7.25 is the current here. This is rated for 14 amps. So once you hit 14 amps, this thing's going to go. All right. So 14 amps, that would be at 28 volts, right? Because the resistance is 2. So let's see. So it's still going, still going. And if there's too much current going through, I'm cranking up the voltage more and more. Notice how the current's getting faster and faster. Once I get to 28, it's going to pop either at 28 or just past 28. So let's see. So at 28, it's good because it's rated for 14 amps. Okay, if I check the current in the circuit, I can't do it with this tool here. Actually, I can. I'm going to break this for a sec. Put this here. This is going to read the current for us. This is another form of an ammeter. So we have 13.97 amps. This is rated for 14, so let's crank this up a little bit, and let's see what happens. All right, notice how the fuse goes. So if this were the case, what you'd have to do is you'd take this fuse and you'd replace it with a new one, like I'm going to do right now. Oh, the fuse goes again. So clearly there's a problem with this circuit. So that's a way to kind of troubleshoot things. So one of the first things people always do is they look for the fuse, look at, okay, is our fuse still good? If the fuse has gone or the circuit breaker's popped, flip the circuit breaker or replace the fuse. If you do that and it pops again like that just did, there's a problem somewhere else. But again, these are so good because they prevent fires from starting. They prevent electronic equipment from getting too hot. All right. So hopefully you know, this is one of those topics you remember for your whole life. This is a really important topic. You're going to use it for the rest of your life, or at least, you know, hopefully you know what you're talking about now when you talk about the circuit box or the circuit breaker box, what it does. That's where the circuit's going to pop if too much current goes through. Reset it, you reset the circuit, you should be good to go again. If too much current comes through again, the breakers pop again. All right? So make sure you fill out your Google form today and